Welcome to Algebra 1, Semester 2, Unit 9, Sections 10.2 and 10.2e. This is a continuation from a previous film. We just have a few problems to go here and we'll be to the next little section. So let's finish this off. We find the axis of symmetry and the vertex, then sketch each graph. Well, we just went over axis of symmetry is... Let me see if I can get my hand in here. Axis of symmetry we find by taking -1/2 b over a. That's the formula that I just gave you on the previous film at the top of the last page. We are at the bottom of page 9, or the top of page 9. So looking up here at our problem, we would have this in standard form. It's always a with the x squared, b with the x, and c that's the constant. So our a value is -2. We come down below here and we plug in -1/2 times -2 on the bottom, and then the b value up there is 12, so we should plug 12 into the top. 12 over 2 is 6, so we have a -1/2 times -6. Half of 6 is 3, and a negative times a negative is a positive. So our axis of symmetry is right down through +3. And what that means is that the parabola's vertex is going to be on that line, and that line will split it in half, make the halves mirror images of each other. So now we come down to finding the vertex. Well, we need to take this 3 because we know that'll be the x value for the vertex. We need to plug it into the equation that was given. So y equals -2. Normally that's an x squared. We plug in our 3 value there, 3 squared, plus 12 times 3, that's the x value, minus 7. 3 squared is 9, times -2 is -18. I think this is just like the previous problem on the other page. If so, then shut off the video without looking at the other page. Try to do this on your own. Clear through the max and min. 12 times 3 is 36, minus 7. -18 and a +36 is a +18. 18 minus 7 is 11. Okay, so we come up to this graph. We're just barely off the graph. We're up here at 11. That's our vertex. You should always write, when I ask you for the vertex, you should always write it as a point. So we had 3, 11. Now it's going to ask us this a max or a min. Well, remember we determine max or min off the very first coefficient. The leading coefficient is negative, so it will be a maximum. That means it's going to be going in this shape. Because remember, max is frown. So, with that in mind, next thing we should do is plug in 2 and see where 2 ends up being graphed at. So we plug in 2 to our x value, -2 times 2 squared, plus 12 times 2, minus 7. So 2 squared is 4. 4 times -2 is -8. Plus 12 times 2 is 24. And then minus 7. I know you saw this on the previous page. That's why I'm encouraging you to go ahead and do it without me and come back in and check in on it. -8 and 24 would be a +12. Minus 7 would be 5. I did something wrong. 8 from 24 is 16. 16 minus 7 is 9. Whew, so sorry about that. Hope I did it right on the back page. I am getting tired on these videos. So 2, 9. And remember, it's symmetrical, so we come up here to 2, 9, make a point, and then we can also make a point on one unit over on the other side of the axis of symmetry. So now let's make sure and mark our C value, which is -7. It's way down here. And 1, 2, 3 over, 1, 2, 3 over this way. So you could either plug in 1 or just go ahead and make the curve with those 5 dots. I'm going to go ahead and just make the curve. I can kind of see how it goes. And that shows me that parabola for that equation. Next equation, definitely stop the video at this point if you can and do this on your own. First thing we come to is the axis of symmetry, -1/2 B over A. Again, write your A, B, and C values right there. So we see that our B is -6, our A is 3, so -6 over 3 multiplied by a -1/2. Negative times a negative is a positive. 6 times 1 is 6. 2 times 3 is 6, so we get a +1 for this axis of symmetry. For our vertex, we plug 1 in for the x in the equation being 3x squared minus 6x plus 2. Plug in a 1 squared. 1 squared is 1 times 3 is 3, minus 6 times 1. 3 minus 6 is -3, plus 2 is a -1. So our vertex is at 1, -1. Now, is it a max or a min? Well, we look at our leading coefficient. It's positive, so we know it's Minnie Mouse. It's a smile. It's positive. Okay, so we come up to our graph. Let's mark this axis of symmetry at +1. And I do like you to write off the top axis that it's A of S, so I know what you're doing there. Then we go to our vertex, which is 1, -1. 1, -1 right there. And next, we need to plug in a couple other points. Well, we know that our y-intercept is 2, so we could go up here and do the 2 and 2. Might not be a bad idea to plug in either +3 or -1. I like -1 better, just seems easier to me. So 3 times -1 squared minus 6 times -1 plus 2. 3 times -1 squared, -1 squared is 1, so that would just end up being 3. Minus 6 times a -1 would be a plus 6 plus 2. So we have 3 plus 6 is 9 plus 2 is 11. So at -1, we're just off the graph, up here at 11. So we go ahead and we, fill in that parabola as roughly as you can sketch that graph. So that's how that works. Now we're into 10.2 section E. This is intercept form. There's formulas here, but I want to make sure that you make sense of this. When we're on the x-axis, what is the value of y? If we look down here, we see these numbers. I know they're hard to see on your page, but you can see them. There's 2, 1, and then something, and then -1. So what's the y value? You should say the y value is 0. So if we plug 0 in there for y, and we solve for x, well, that tells us where this graph is crossing the x-axis, wouldn't it? So with that in mind, we don't have to worry about this negative out here, because we know when this times this equals 0, that one of these or the other one is 0. When x is at -1, it's 0, and when x is at +5, it's 0, because that's what number would make that be 0, that's what number would make that be 0. So that really is telling you that your x-intercepts are at -1 and +5. So when you look up here at the formula, see how it has a -p and a -q? Well, because the formula contains that negative, you know that your x-intercept is the opposite of what it looks there and the opposite of what it looks there. Just how we got the -1 and the +5. Okay, review the tape for this if you need to. Now, when we look out in front, it's got a negative, so we can picture this. It's going to be a maximum because of that leading negative. To find our axis of symmetry, well, does it make sense that it would be halfway between these? Because your axis of symmetry always splits your parabola in half, just like it did up here. So halfway between -1 and 5, we could either add these up and do it mathematically. Halfway between would be 4 divided by 2, or 2. Or you can do it graphically and just count in 1, 1, 2, 2, 3, 3. There's my axis of symmetry right on that 2. Please label it up above, just like I asked you to in the other section. Now, all that we need to do to find our vertex is plug in that +2 to our equation. So our equation was y equals negative x minus, or x plus 1 and x minus 5. Now all we need to do is plug in that 2 for x. So we have a negative x plus 2 is 3. 2 minus 5 would be a -3. So we have negative times 3, which is -3, times -3, which equals 9. So our vertex is 2, 9. We come up here and we go off the graph. I didn't give you a big graph like I did on the others. Let's count by 2s instead. No, let's go ahead and just take it off the graph. So 5, 6, 7, 8, 9. Be about right there. I'm okay with a rough estimate. Okay. Well, now we should look for another point, maybe at 1. 1 wouldn't be hard to do. So we can plug 1 into our equation. Negative 1 plus 1, 1 minus 5. 1 plus 1 is 2. 1 minus 5 is -4. And then bring down that negative. -2 times -4 is +8. We'll be right there on that one. And that gives us 5 points. That should be good enough to give us an estimate. So that's what our parabola looks like. Okay? That is intercept form when you have the binomials being multiplied. At the top of the next page, page number 10, I explain how you use the formula. I really wanted you to have the reasoning first. When a is greater than 0, that value out there, then we have a mini. And you can get a stretch or a shrink on that mini. And when a is less than 0, you have a max. And again, you can have a stretch and a shrink there. That's a negative. This is positive. Okay? So the axis of symmetry, again, as I showed you, it was your P plus your Q divided by 2. Remember, they're the opposite of what they look due to the negatives in the formula. And then you'd simply take that axis of symmetry, plug it in for your x value to find your vertex. And then you'll come out with your solution right there as your vertex. The x-intercepts are the PO or P0 and Q0, just as we graphed. Okay, that is the end of that section. Thank you very much.